Okay. Once again, good morning, everybody. In the previous session, we looked into Ohm's law. Can anybody state the Ohm's law?
It states that at constant temperature, the current flowing through circuit is directly proportional to voltage developed across circuit.
Okay, voltage applied across the conductor or the conducting material. That is correct. So, at constant temperature is very important condition. Uh, if that temperature is constant, the current flowing through the conductor is directly proportional to its the voltage applied across. If the voltage applied across the conductor is more, the current is more. So if it is less, the current is less. So that is directly proportional. And the relation, the Ohm's law, in terms of mathematical equation, it is given as V is equal to IR. And then we looked into a DC circuit. DC circuit is nothing but a circuit where the resistors are connected end to end. Okay, so they are connected end to end so that it makes one path, and that combination is connected across the voltage source. So what is the characteristics of a DC series circuit? Whatever the applied voltage is equal to the voltage drops. This is also called as a voltage drop. There are different terminologies that are used. One is potential difference across R1, voltage drop across R1, potential difference across R1, all are the same. So whatever the applied voltage, it will get distributed among all the resistors which are connected in series. So we can say that applied voltage V is equal to V1 plus V2 plus V3, and applying the Ohm's law at each of these resistors. So we know the what is the current flowing here. The current flowing is I. Whenever resistors are connected in series, they will be carrying the same current. The amount of current that is carried by all the resistors is exactly the same. If 5 amperes is flowing, 5 amperes will flow here, 5 amperes will flow here, and 5 amperes will flow here. So that is represented as I. And we can apply the Ohm's law at each of these resistors. And what is the uh, Ohm's law? If we apply for the resistor 1, V1 is equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. Notice I is same, and we know V is equal to V1 plus V2 plus V3. So if you replace with these values, finally we will come as V is equal to I into R1 plus R2 plus R3. So V by I is equal to sum of all the resistors. So in case of a series circuit, that is, if resistors are connected in series, the effective or the effective resistance of that particular circuit is given by the sum of those resistors. Means what? These resistors, three resistors can be replaced with a single resistor whose value is sum of all the resistances. So yesterday I gave an example. Let us say this is a 10 ohm, 10 ohm, and 10 ohm. Three resistors are connected. It is equivalent to having a 30 ohm resistor connected to the same voltage source, which will result in the same amount of current. Okay, this is the equivalent circuit RS. So we can say V, if I replace if for the applied voltage V, if I place a resistance which will result in the same amount of current, then I can write V is equal to IRS, V by I into RS. So this particular resistance is also resulting in the same current for the applied voltage of V. Therefore, we can say that the equation 1 which we got earlier and equation 2 are equal. So their left hand side is equal, V by I. So their right hand side can be compared, that is RS is equal to R1 plus R2 plus R3. So it is called as a effective resistance or the equivalent resistance. Okay, these are the main characteristics of the series circuit. In exam, they might ask the characteristics of the series circuit and characteristics of the parallel circuit. So what are the characteristics of the series circuit? And some of the characteristics already you uh, specified with the earlier questions. Some of the characteristics you already know. So first, what is the characteristic? If resistors are connected in series, the amount of current that is flowing in each of them would be exactly the same. Okay, that is the first characteristic. And second is the total resistance of the circuit will be equal to the sum of the individual resistances that are connected in series. That is RS is equal to R1 plus R2 plus R3 plus so on plus Rn. So the number of resistors that are connected in series can be effectively replaced by sum of their resistances. And what is the power? The total power dissipated in the circuit is equal to the sum of the powers dissipated in the individual resistances. So the total power that is consumed by the complete circuit is equal to sum of the uh, power consumed in the individual resistances. This is similar to the one example that we solved about the lamp. They In that particular question, how many kilowatt is consumed by such and such lamp? Okay, 250 lamps with some specification. What we did was we calculated what is the power consumed by the one lamp, and then we added all the power consumed 250 times. So it is 250 times the power consumed by the individual lamp. In this particular case, the same thing holds. I have resistances R1, R2, R3. What is the total power consumed by the circuit? It is the power consumed in R1, power consumed in R2 plus power consumed in R3. So equationally, we can prove like this. We know that Rs is equal to R1 plus R2 plus R3, isn't it? So in case of a series circuit, the effective resistance is equal to sum of the resistances. That is the statement. If I multiply I square on both the sides, okay, left hand side and the right hand side, what I get is I square into Rs is equal to I square into R1 plus I square into R2 plus I square into R3. And we already know the equation of the power. Okay, it can be represented in three different forms. P is equal to VI, P is equal to I square R, or P is equal to V square by R. Now, this I square into Rs, this represents the total power consumed in the circuit. That is represented by P. I square into R1. I square into R1 is the power consumed in the resistor R1. So if I show you the circuit, so I square into R1, that is the power consumed in resistor R1. The same current I square into R2, power consumed in resistor R2. I square into R3, power consumed in the resistor R3. We represent this as P1, P2 and P3. That is how we get this equation. P is equal to P1 plus P2 plus P3. That is total power consumed in the circuit is equal to sum of the powers consumed in the individual resistors that are connected in series. Next one, the total voltage of the circuit is equal to the sum of the potential difference across each resistor. Okay, so how to prove that? Same, Rs is equal to R1 plus R2 plus R3. Multiply I on both the sides. What we get? I into Rs is equal to I R1 plus I R2 plus I R3. And from Ohm's law, we know that V is equal to IR. And this represents the effective resistance. I into Rs is nothing but V or Vs. This is the actual, sorry. This is the I into Rs is nothing but this one V Then I into R1 is V1, I into R2 is V2, I into R3 is V3. So whatever the voltage that is applied to the series combination is equal to voltage across sum of voltage across each of these resistors. And the last property is any open circuit causes the circuit to be dead or the current flowing will be zero. If there is any disconnect, any if anywhere in the series path, if there is any open wire, then the current will be zero. So any open circuit will cause the current to become zero. As long as it is connected, only the current will flow. If there is any disconnect or open circuit, current will cease. The circuit will become dead. Okay, this is the problem. I hope everybody is ready with the book and the pen and the calculator. We'll solve the problem. Two filament lamps A and B takes 0.8 ampere and 0.9 ampere respectively when connected across 110 volt supply. Calculate the value of current when they are connected in series across 220 volt supply, assuming the filament resistance remain unaltered. Also find the voltage across each lamp. Okay, so first thing is here is the assumption, assuming the filament resistance remain unaltered. The reason being, when you keep the lights on, heat is produced, temperature will increase. We will not consider that. We'll assume that resistance will remain same, it will not change. And if they have not specified, you have to take resistance will remain same. What we have to do is two filament lamps A and B takes 0.8 ampere and zero point 0.9 ampere respectively. So when connected across 110 volt supply, lamp A, it is connected to 110 volt supply, it takes zero point 0.8 ampere, and lamp B, when it is connected across 110 volt supply, it takes 0.9 amperes. So you understand, A is connected to 110 volt, B is connected to 110 volt. A circuit, it will take zero point 0.8 ampere, B circuit will take zero point 0.9 ampere. What we have to calculate the value of current when they are connected in series across 220 supply. Now individually, when they are connected to 110 volt, A will take zero point 0.8 amperes and B will take zero point 0.9 amperes. Now let us say we connect lamp A and lamp B in series and across 220 volt supply. Okay, what we have to find, first is the calculate the value of the current. If we connect A and B in series to 220 volt, we have to find the what is the current. And second, we need to find voltage across each lamp. I hope everybody understood the problem statement. Start working on the solution. What would be the current? What would be the first step?
Is equals to I1 plus I2. You should
Mm,
find the total
we should find.
the total
Resistance.
current
Okay.
first.
Somebody said
Res,
resistance. Yes, we have to
resi,
find the resistance first. And how do you find the resistance?
V upon I.
Yes. See, for each of the lamp, current is given and voltage is given. So you can easily find the resistances. Find the resistances Ra and Rb. And I told you, whether it is a filament lamp, any kind of a load, it will be converted into resistor. It is always represented as a load is represented as a resistor. So you can take the resistance lamp A as Ra, lamp B as Rb. What is Ra?
137.5.
137.5 ohm.
137.
Very good. I hope everybody is doing it. Okay, somebody. Okay, RA 137, RB 244.4. How much is RB?
44.4.
240,
Sir, 122.2.
122.2. Okay. So,
122.2 ohm.
okay, very good. So, first one is RA 110 divided by zero point 0.8. So that will come as 137.5. Why 110 divided by zero point 0.8 is for RA, the voltage is 110 divided by zero point 0.8 is the current V by I. And for second one, 110 divided by 0.9. So in case of a lamp B, the voltage is 110 divided by current is 0.9. See, we get it as 122.22. Then what is the next step? As,
RS
yeah, tell me.
total resistance.
Yes, correct. Because we are,
59.72.
Mhm. What is the current? So 122 plus 137.5, we get it as the effective
259.
resistance 259.72. So when resistor RA, that is 137.5, is connected in series with RB 122.22, we get effective resistance is RA plus RB. That is RS is equal to RA plus RB. That will come as 259. And this series combination is connected across 220 volt supply. The question is, calculate the value of the current when they are connected in series across 220 volt supply. So we have to find the current. What is the current?
0.84.
0.8.
0.84.
0.8.
0.84.
Oh, very good. 0.84. Once you get 0.84, how do you calculate the voltage across lamp A and voltage across lamp B? How do we calculate the current, total effective current? I is equal to
V
V,
by R.
V by RS, right? In case we have RS and V is given as 220
220.
divided by 259.72. 220 divided by 259.72. If I say this, we get it as what you do is like take up to the third decimal 0.847. Since in the fourth position it is 0, it will remain 7. Try to round off, at least take 3 position, 0.847. Now how you will calculate the voltage drop across the resistor lamp A or resistor A? VA is equal to
I into RA.
I
I
into
by
RA. I into RA. V is equal to IR. Just replace V is equal to I into RA. So 0.847 multiplied by RA is how much? 137.5. How much you get?
116.4.
Very good. Okay, take two digits. After the decimal, at least take two digits. And how do you calculate the voltage across the lamp B?
VB is
V2
equal to
V
RB.
VB is equal to
I into RB.
I into RB. Is there any other way? That is one way. That is correct. I into RB. Is there any other way?
Total voltage minus VA.
Very good. V is equal to VA plus VB, right? So you already, V is given as 220. VA you already calculated. Therefore, VB is equal to V minus VA. That is 220 minus 160, 16.46. That's another way. If you calculate VB is equal to I into RB, when you add both the values, you may not get exactly 220, very close to 220 because of the rounding errors. But if you use the other method, V is equal to VA plus VB, then you will get the exact value. Very good. So we'll see the solution. Already you have found the solution. Uh, Others, please, I want everybody to work out on these problems. Okay. If you are not understanding, ask the question. So first you will draw the circuit diagram. Always whenever the problem is given, first thing you have to draw the circuit diagram, label all the components. Lamp A is represented by, you can represent just a resistor. You don't need to represent the lamp. One resistor RA, IA is given 0.8, VA is given 110 volt. Therefore, RA is equal to VA by IA, that will come as 137.5. Similarly, RB circuit diagram, IB is given 0.9, VB is 110 volt. Okay, then therefore RB is equal to VB by IB, 110 divided by 0.9, 122.2. Okay, 22, then better. And if you want to say this as I1, I2, that is also fine. It is representation is left to you. Then we connect the both the lamps in series, and we already know the resistances of those lamps. Ra is 137.5, R3, Rb is 122.2. They are connected in series. Now we have to find the current. Current is unknown, and they are connected across 220 volt. And Va, that is the voltage across Ra is unknown. Vb, voltage across Rb is unknown. Those things we have to find. And since it is a series connection, Rs is equal to Ra plus Rb. Therefore, Rs is equal to 259.7. That is the effective resistance of the circuit. And once we have Rs value, how to calculate the current? I is equal to V by Rs, 220 by 259.7, 0.847. And voltage across the lamp, Va is equal to I into Ra, you will get 116. Then voltage across lamp VB is equal to I into RB, that you will get 103.5. So either you can use this formula, or you can say V is equal to VA plus VB. So already you know VA is calculated, VB is equal to V minus VA. Okay, take the next problem. Excuse me. If the resistances of a circuit having 12 volt source is increased by 4 ohm, the current drops by 0.5 amperes. What is the original resistance of the circuit? So first we will understand the problem. If the resistance of a circuit having 12 volt source, means there is a resistance and it is connected to 12 volt source. If this resistance value is increased by 4 ohm, okay, if we increase the resistance by 4 ohm, the current will drop, means current will reduce by 0.5 amperes. What is the original resistance of the circuit? So how you can start with this problem is, initially the condition is they have connected one resistor and they connected to 12 volt source. Now some amount of current is flowing in that particular circuit, and in the next second scenario, what they have done is they have added 4 ohms to the original value. Okay, let us say the original resistance is R naught. Because it is not given, we represent R naught or original R naught. And in the second scenario, if I add 4 ohms, if I add 4 ohms to R naught, what it will become? R naught plus 4. And initially the current, let's say in the first original circuit, the current that is flowing is represented by capital I. In the second scenario, what happens? The current drops by 0.5 ampere. Means current will become, originally it was I, now it will become I minus 0.5. So connected to same voltage source, 12 volt. Okay, so what you have to find? You have to find the original resistance. Can you find it? Can you find it? Yes or no? Where to start?
No, sir.
Okay, at least you understood the problem.
Yes, sir.
Yes, sir.
Okay. Maybe I will just show the circuit diagram. Okay, so this is the hint for you. Okay, the original circuit, initially what has happened, this is the original circuit. We don't know the resistance, unknown resistance is given R naught, and it is connected to 12 volt. And let us say amount of current that will flow if you connect it to 12 volt is I naught. The amount of current that will flow is I naught. So this is the original setup, first setup. Then in the second scenario, they have assumed there is a one more circuit diagram, one resistor. Here R naught plus 4 ohm, right? The new resistance is what? R naught plus 4. You can see this R naught 4, R naught plus 4. What would be the resulting current? I naught minus 0.5. And what would be the voltage? 12 volt. Now can you solve it? See, for this we have already applied Ohm's law. V is equal to I naught R naught. Okay. Therefore, 12 is equal to I naught R naught. This is the first condition. If there are two unknowns, how many equations you will need?
Two, sir.
Two equations, right? So this is the one equation you got. And what is the new scenario they have given? Second scenario. Here, the second scenario R naught plus and I naught minus 0.5, and it is connected to 12 volt. Can you do it now? What would be the second equation? Okay, I think let me explain this. Okay. Okay. So everybody understood the first scenario, original scenario. Some unknown resistor R naught is connected to 12 volt. It will result in current is not given. So I will say I naught. This will result in I naught current. So I apply Ohm's law. V is equal to IR. V is equal to I naught into R naught. That is 12 into I naught R naught. Therefore, I naught R naught is equal to 12 is the first equation. Everybody followed this?
Yes, sir.
Okay. Now, in the next circuit diagram, what happens? The new value of the resistance is R naught plus 4, and R naught plus 4 is connected to 12 volt. When R naught, the resistance of the original resistance is increased by 4 ohms, the current will reduce by 0.05. So the new resistance R is equal to R naught plus 4, and the new current I is equal to I naught minus 0.5. Okay, and we will apply the Ohm's law, and it is connected to same 12 volt. V is equal to IR. Now V is 12 volt. And what is the new current? The new current is I naught minus 0.5. And what is the new resistance? R naught plus 4. And if you simplify this, what you get? 12 is equal to I naught R naught plus 4 I naught minus 0.5 R naught minus 2. Okay, this is the second equation that you will get. Okay, now from the first equation, what is the first equation? First equation is what? I naught R naught is equal to 12. So you can take one of them as the unknown and replace the other value. So from equation 1, I naught R naught is equal to 12. Therefore, I naught is equal to 12 divided by R naught. So wherever there is a I naught, replace with 12 by R naught. So this is I naught 12 by R naught, and this is 4 I naught, 4 into 12 by R naught minus 0.5 R naught minus 2. Okay, and if you simplify this, what you will get? You will get a quadratic equation. R naught square plus 4 R naught minus 96 is equal to 0. Everybody understood until now what has happened?
Yes, sir.
Okay. Now you ended up with a quadratic equation. How many roots will be there for a quadratic equation?
2.
Two roots. Okay, so this will give two values, and we have to select one among them. We will see what answers you come up with, and everybody knows how to solve the quadratic equation. What is the root of a quadratic equation? What is the formula? If the quadratic equation is of the form ax square plus bx
Plus BX.
plus c is equal to 0, then what would be the roots? X is equal to,
So,
okay, the general quadratic equation is ax square plus bx plus c is equal to 0. This is a general quadratic equation. So what would be the roots of a quadratic equation? X is equal to minus b plus or minus square root of b square minus
B square
4a
minus 4AC by 2A.
2a. That is
Sridhar Acharya's form.
yes. So this is of the form ax square. Here it is r naught. Ax square plus bx plus c. What is the a value here? A is 1. A is equal to 1. B is
4
4. C is
and minus
Minus 26.
minus 96. So put in the formula, r naught is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So a is 1, so it is divided by 2. So you have to use plus to find the first root, minus to find second root. Minus b plus or minus. So you have to use plus ones and minus ones to get the two roots. What are the roots?
8 and minus 12.
8 and minus 12. Did anybody else got the answer? 8 and minus 12. Okay, Giridhar. Okay, Vinanti. Okay, so answer is 8 and minus 12. Good, Adarsh. Okay, I hope everybody is attempting it. So can resistance become a negative number?
No, sir.
No. So
Should take positive.
we have to discard that minus 12 and take the value of resistance as R naught as 8 ohm. Okay. Once you know the value of R naught is 8, what is the value of I naught? You can
1.5.
uh, okay, I naught is equal to 12 divided by 8, so it will come as 1.5, correct, 1.5. Now what you can do is, now if you want to verify the answer, go to original. What is R naught here? R naught is 8, right? And what is the I naught you found? 1.5 amperes. If you, what is the voltage? V is equal to I naught into R naught. 8 into 1.5 is 12. And similarly, 1.5 is the current, so you can easily guess what would be the new current here. It would be 1 amperes. 1.5 minus 0.5, 1 amperes. How to verify? R naught is 8, 8 plus 4, 12 volts. I is equal to V by R. V is 12 divided by 12, that is 1 amperes. That is how it reduced by 0.5 amperes. Everybody understood? So this is the two roots of a quadratic equation. R naught is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. In this particular case, a is 1, b is 4, c is minus 96. We are going to substitute those values. Minus 4, and once you calculate, you get the two values. R naught as minus 2, it cannot be negative, resistance cannot be negative, so we'll take R naught as 8 ohm. Okay, the current is not calculated. You can calculate the current and you can validate. Okay, any questions in this previous problem? If you have questions, please put it in the chat section if you don't want to talk, or you can ask question. Everybody understood the problem? Okay. I hope everybody understood. Let us go
Yes.
to the next. Okay. Let us go to the next problem. A 100 watt 250 volt lamp is connected in series with 100 watt 200 volt lamp across 250 volt supply. Calculate circuit current, voltage across each lamp. Assume the lamp resistance to remain unaltered, means with the temperature resistance will not change, so we have to assume temperature resistance will remain same. So first we'll understand the problem statement. We have two lamps and they have given the rating for the lamp. I told you inside your household you have 9 watt, 14 watt, 20 watt lamp, right? Different wattage lamps. So that way, in this particular case, they have a first lamp which is 100 watt and 250 volt, and this lamp is connected in series with another lamp which is 100 watt but 200 volt. The specification is 100 watt and 200 volt. These series, they are connected in series and they are connected across 250 volt supply. They are connected across 250 volt supply. What we have to find is circuit current, that is what is the current that will flow in the circuit, voltage across each lamp. So voltage across lamp A and lamp 1 and lamp 2, whatever you want to call. So 100 watt 250 volt, and this is uh, this is 100 watt and 200 volt. So calculate. How to calculate? How you will start? Every time first is like understand the problem statement, draw the circuit diagram, write all the values, then you start your approach how to solve this. Okay. uh, to find the current, voltage is given, isn't it? To find the current, now I is unknown, V is equal to IR, we need to find I. V is given, so what we should try to calculate? Resistance. Right. If we know V and R, we can calculate the third one, that is I. How you will calculate the R here? Resistance. Any ideas? So what you have
Power
to,
formula.
yes, okay, power is given.
Yes, sir.
So you have to think about the equations where R comes. One equation V is equal to IR, right? So we cannot use that. I is not known, and since power is given, there is one more equation that we can use for power where R comes. What is that equation?
P is equals to
P is
VI.
equals to
Huh. P is equal to
I square
VI.
P is
uh,
equals to I square
I
R.
square R I square
I,
R.
I square R is one form, but I we don't know. V is given
Sir,
in
P
terms
is
of
equals to VI. P is
bar.
equals to VI.
I is not known.
P is equals to V square bar.
Very good. P is given. Okay. V is given. P is equal to V square by R. Okay. Only one unknown. P value is known. V value is known. R is unknown. We can calculate, right? P is equal to V square by R. You can use that. So you this one resistance R1, voltage is V1. This is R2, V2. So here you can say P1 is equal to V square V1 square divided by V square by R. Okay. So you can rephrase that R is equal to V square by P. That is how you will find the resistance. What is the value of R1?
625 ohm.
25.
625 ohms is correct. It would be like 250 square divided by 100. 250 into 250 divided by 100, that will end up with 25 into 25, 625 ohm. R1 is equal to 625 ohm. R2, you have to use only these values. V square divided by P. R2 is equal to this V square divided by this power. How much you get?
416.16.
400.
16.6.
No.
400
Any
ohm.
400.
400 ohm, Atiya. It is here, that would be V square by P. V is nothing but 200. If it is not very clear, it is 200 ohm, 200 volt. 200 square divided by 100. That will come
400
as
ohm.
400 ohm. Now you can find the current, right? Now you know the resistance. This one is 625 and this is 400. Okay, even though answer is on the screen, please try to work out. Those who are not able to understand, just take a look here, while others you calculate the just the current on your own. Even though answer is here, try to calculate and then try to match. Okay, so this is the rating that is given for the lamp one, 100 watt and 250. Second one is 100 watt and 200 volt. Using these specification, we calculate the resistances. Okay, resistance of 100 watt 250 volt lamp, R1 is equal to, this is what is the formula we are using, R is equal to V square by P. How we got it? P is equal to V square by R. Rewriting that equation, R is equal to V square by P. And for the first lamp, 250 is the voltage square divided by 100, that will come as 625. For the second lamp, the rating is different, voltage is different, 200. This is the specification given for that particular lamp. R2 is equal to 200 square divided by 100, that will come as a 400. Now we know R1 is 625, R2 is 400 ohm. They are connected in series. What is the effective resistance of the circuit? RS is equal to R1 plus R2, 625 plus 400. We get it as 1025. That is the RS value, total resistance of the circuit. Once we know the total resistance of the circuit, we already voltage, applied voltage is given as 250. We can calculate the unknown I. So current in the circuit is equal to I is equal to V divided by R. V is 250 volt divided by total resistance is 1025, and we get the current as 0.244 amperes. I hope everybody got it, this current.
Yes, sir.
Okay. Now what you have to
Yes,
find?
sir.
Voltage drop across each of those resistances. What is the voltage drop? See, this 0.244 amperes is the current. The same amount of current will flow through R1 and R2. So what is the voltage drop across the first lamp? V1 is equal to
I1 into R.
I into R1. I is the same. I into R1. I is
R1.
0.244 into 625. And similarly, V2 is equal to I into R2. R2 is 400. What is the answer you get?
2.5.
152.5.
Okay. If you want to verify your answer, if you add both the values, you should approximately get a 250 volt. So voltage across each lamp, V1 is equal to I into R1, 0.244 into 625. We get V1 is equal to 152.5 volt, and voltage across the second lamp, V2 is equal to I into R2, that is 0.244 into 400, that you will get it as 97.6. Okay, I hope everybody understood. Okay, all of you start writing down these equations in the book. Okay, whatever the book where you are making the notes, start solving. And in the examination, you have to write like this. You have to solve like that in order to get the complete marks. Just don't write the equations and do the calculations. Okay, you have to explain how what you are doing, how it is coming. Okay, try to have the problem solutions like this, where you have a description of what you are doing and the calculations both together. Okay. Next problem. What is the voltage drop across the 150 ohm resistor in below circuit? Okay. So this is the circuit given. Only in the circuit, what you see is there are multiple resistors and multiple voltage sources. First thing is, what we have to find? We have to find the voltage across this. How I can find the voltage? If I know the current, V is equal to IR, I can find the voltage. First thing, is this circuit, the resistors are connected in series or parallel? That is the first thing we have to decide.
Parallel.
Parallel, sir.
Parallel.
Parallel.
Anybody want to say it is series?
Sir, series, sir.
Okay. If you say series, why?
Sir, the next diagram, the
It is connected to end to end.
into
Very
end-to-end
good.
fashion.
So it may not be clearly visible, it is connected to end to end. We will go back for the one characteristic. If you understand that characteristics, then you will say this is in series. Okay. What is the first characteristic? The current in each resistor is the same, right? What is the, it says current in each resistor is the same. Then we'll come back. So how many paths are there? Possible paths for the current? There is only one possible path, right? Isn't it? Current has to flow only in this path. There is no other path. When there is only one path, same amount of current has to flow through all the components. Isn't it? Is that true?
Yes, sir.
Okay. When same current is flowing through 47 ohm and 150 ohm, that means that they are connected in series. Okay. So, and that is how we just add it here. And this voltage sources, even though there are multiple voltage sources, if you remember, you have the at home torch, right? The torch, and in that you put the batteries, isn't it? Sometimes you put the three batteries. So how, one battery is for 1.5 volt. Then you put the positive end first, and negative would be the on the other side. When you put the next battery, you put the positive. Means if I draw that positive, negative, positive, negative, and you put one more battery, that is positive and negative. If you effectively see 1.5 volt, three batteries, it will become 4.5 volt. Means all those are added, all the voltage sources are added, isn't it? When you connect positive, negative, and positive, negative, it will add. If you connect, if you put that battery in the reverse direction, so effectively what happens, it will become, let us say you put first battery as positive, negative, second battery as positive, negative. So what happened? 1.5, 1.5, 3 volt. And third battery you put reverse. So this will become negative and positive. Actually, it will try to send the current in the opposite direction. So what will happen? 1.5 plus 1.5 minus 1.5. Effectively, it became 1.5 volt. Similarly, if the batteries are trying to send the current in the same direction, their value will get added. If they are trying to send the current in the opposite direction, then their values will decrease. Means whichever is more minus the lesser one. So coming back to this diagram, we will see here this particular battery, right? We already know that EMF sources, the current will flow from positive to negative. So this battery is trying to send the current in this direction, and this battery is trying to send the current in this direction. So basically they are opposing each other. So what would be the effective voltage? The effective voltage would be 22 minus 15 volt, right? If this was a negative terminal and this was the positive terminal, this is trying to send the current in this direction and this is also trying to send the current in the same. So then it will become 22 plus 15. I hope everybody understood. The reason why we are deducting 22 minus 15 is this is trying to send the current in the opposite direction to this voltage source. This is trying to send in this. So effectively, how much is the voltage source that we have for this circuit? 22 minus 15. That comes as a 7 volt. Everybody understood that?
Yes, sir.
Okay. So
Sir,
effective, yeah, tell me. Any questions? Okay, if you are having any type of a question, you can put it in the chat section also. If I'm in between, if I'm speaking and you get a question, you put it in the chat. Okay, then I will answer it. So effectively what happened, this, because there is a same current flowing through the both the resistors, that is why these resistors are in series. And we know that when two resistors are connected in series, their effective resistance would be sum of their resistances. Therefore rs is equal to 47 plus 150, that is the total resistance of the circuit, which is 197 ohm. And for the voltage sources, in this particular scenario, the this voltage source is trying to send the current in the opposite direction of this voltage source. That is why effective voltage source that is present in the circuit is 22 minus 15, that is 7 volt. So then now it is a very simple circuit. So you have 197 here, and voltage source is V is 7 ohm. Okay, you should be able to calculate the current. So as a just a homework, take this problem, solve it, and what is the thing you have to find out? You have to find the voltage drop across 150 ohm. So in the tomorrow's class, we will begin by getting your answer. What is the voltage source across 150 ohm?